Hi, everybody. This is the Test 3 review for the 1442 class. What I did was I went into modules, then I went to our homework system, and I went to Chapter 5, 6, assignments for Test 3, and scroll down to the review for Test 3. So I got some problems off of the review for Test 3. Here's the review. What I did was I found problems similar to the test on this review, and I'm going to cover them in this review session. All right. So the first thing I did was I went to problem 1. Now, your problems may be a little different from mine. I mean, it's the same type of problem. The numbers might be a little different because for each person, they usually make the numbers a little different. So for question 1, it says find the mean. Here we're finding the mean. A country highway reports the number of accidents. So what we want to do is we want to put X in L1 and probability of X in L2. So first thing, that's what we're going to do, put those in our calculator. 0, 1, 2, 3, 4, and then 0.3, 0.2. Let's see if I can actually put that in there and see it. I don't know if I can see it at the same time. I don't think I can. Give me a second. All right, so now I have it set up. We're going to go to the list 1 and list 2. So we're going to hit, by the way, this class is designed for the TI-34 plus calculator. I hit stat, number 1, edit, hit enter. And I'm going to type these numbers into list 1 and list 2. If I want to clear my list, I just hit clear. Don't hit delete. I go up to and hit enter. I go over here, but you have to go up to list 2, hit clear, and hit enter. So I have to type in 0, 1, 2, 3, 4. And in list 2, I had 0.3, 0.2, 0.2, 0.1, and 0.2. So this is all the data I had in here. You see my data matches my calculator. So to find the mean, I hit stat, arrow over to calculate, 1 var stats. Make sure in list you have list 1 and frequency list. If you don't have anything in there, you have to hit second and the number 2 button. I know you can't see that. The number 2 button, because right above 2 is the L2. And it'll put the L2 in there for you. Hit enter. And this 1.7 is our mean, our average. So our answer for this problem using the calculator is 1.7. We went to stat number 1, edit, and we added everything into list 1 and list 2. Once we had everything in list 1 and list 2, we went to stat, arrow over to calculate, then went down to number 1, var stats. We made sure L1 and L2 were in there. And we found this number on our calculator after we hit enter a couple of times. It should have said 1.7. So that's how we did that on our calculator. All right. So let's try the next slide. The next slide is problem 3 of the homework. For the number of heads when 15 coins are tossed, so n is the number of trials, 15 coins are tossed, find the mean. Well, the probability of getting a head is 0.5. The probability of getting a tail is 0.5. Since you have two choices, head or tail, yes or no, true or false, those are all binomial distributions. And to find the mean for binomial distribution on your in your workbook, if you ever follow along on your online workbook, page, let me look, I think it's 137. No, I don't know. I don't have the page in front of me. It shows you all the formulas for mean, standard deviation, and variance. Go to page of the online workbook. Page 137. It shows that the mean equals n times p. It also shows variance equals npq. And just to show you, n is the number of trials, p is the probability, q always equals 1 minus p. So the p and q have to add up to 1. If p is 0.5, then q is 1 minus 0.5, which is also 0.5. If p is 0.7, then q is 0.3, because they have to add up to, once again, they have to add up to 100%. And then if you want to find, by the way, this is standard deviation. That's the variance right here, formula for the variance. And the formula for standard deviation is the square root of n times p times q. So the formula for the mean for a binomial distribution is n, which is 15, times a probability 0.5. So the mean is 7.5. 15 times 0.5. All right. Let's go to the next problem. Compute the probability. This is binomial distribution, and we want to find x equals. Binomial distribution x equals. So let's do this on our calculator. So just remember the numbers that you have on here. N is 7, P is 0.2, and X equals 3. So that's kind of important. X equals 3. So let me bring this up. And well, let me show you. On our calculator, we hit second. For binomial distribution, we hit second vars on our calculator. So let me show you that. Let's turn it on and hit second vars. Do you see right about vars is distribution? Second vars. And we have to find binomial distribution. I'm going to scroll down all the way to A and B. Binomial PDF and binomial CDF. Well, PDF is for equals. We have to use binomial PDF for equals. Hit enter, and it says the number of trials. And if you look, the number of trials for us was 7. It says the p-value, the probability, and it said 0.2. And the x value is equals 3. So everything's in here. They gave us all this. We're just going to hit enter, enter, and enter one more time. And there's our probability. And we always take it to 4 decimal places, 0.1147. Since the 5th decimal place is 5 or more, we have to take it to 0.1147. So the answer to this would be 0.1147. Once again, second vars, scroll all the way down. There's an A and there's a B. A is Binomial Pdf, if I could spell PDF. And B is Binomial CDF. PDF is anytime x equals something, and CDF is when x is less than or equal to something. So that's the difference between binomial PDF and binomial CDF. I think I put this out on a video if you look in the module section. All right, so we had to use A because the problem says x equals 3. Okay. So, by the way, that was problem 8 of the homework, if you look up here. Let's go to the next problem. Find the z value that corresponds to the given area shown. So they give us the area. They give us the area, and we have to find this z value. There is a function on our calculator, second vars, once again. Type in the second vars button. And we're going to go to second vars number 3, inverse norm. Let's see, second vars, inverse norm. There we go. And it's going to ask for the area. The average when we do this should be 0. Standard deviation should be 1. So we just have to type in the area. Now this is the thing in this function for the calculator, inverse norm. If to find this z value, you can't type in this area. You have to type in the area to the left of the z value. We have to type in this area because your calculator will only do the calculations for the left of the z value. So to find this z value, I have to type in this area. Well, we know the entire area is 1. So this area is 1 minus this area. This area is 1 minus all this, and that's 0.6057. So on my calculator, you can just do 1 minus 0.6057, or for the area, you can do that, but I'm going to go ahead and calculate first. 1 minus 0.6057, and I typed in something wrong. 6057. I still typed in something wrong. 0.6057, and I get 0.394. So this area is 0.3943. 0.3943. So that's what I'm going to type into my calculator. I'm going to second vars, number 3, inverse norm. And the area is going to be what I said it was. I can't remember a thing. 0.3943. All right. 0.3943. and it's going to tell me my z-value once I hit enter again. And the z-values we only take to 2 decimal places. So look at the third, 5 or more, it's negative 0.27. So our z-value is negative 0.27. That z-value right there. Do you see here's 0? All z-values to the left of 0 are negative. All z-values to the right of 0 are positive. So that z-value is negative 0.27. We went inverse norm. We put the area, and area always has to be the left of the z-value you're looking for. Always. And that's why we typed in 0.3943 instead of this 0.6. Because when you're looking for a z-value of a particular spot, you have to type in the area for the inverse norm to the left of that. All right. Next problem. Find the z-value to the left of the mean so that 59% of the area of the distribution lies to the right of it. What? Let's draw this picture, try to figure out what they're trying to tell us. So this is a normal curve. It's supposed to be a normal curve. Here's the mean, the average. Find the z-value to the left of the mean so that 55.96 of the area under the distribution curve lies to the right of it. So let me change my color. First of all, 50%, each one of these, each side is 50%, right? 50% of our data. It's supposed to be a normal curve. So that's 50%. So we want to find out where 55.96 it lies to the right of the value. Find the z-value. So we're looking for this z-value where 55.96% lies to the right of it. Do you see? That's what it says. So we know this is a z-value of 0. We know our answer is going to be negative because the z-value is to the left of 0. So we know now the area that we're shading in is 55.96. To put that in decimal form, this is what your area would be. So we need to find this z-value just using the same inverse norm as we did. However, the z-values that we put into the calculator will only do to the left of the line that we're looking for. So to find the z-value, we have to have this area, and it's 1 minus 0.5596, which is 0.4404, right? When you subtract those two, 1 minus 0.96 is this. So sorry, I'm trying to write. It's not letting. There we go. So this is that area. So we're going to do the inverse norm again. And our area we're typing in is 0.4404. 0.4404. So on my calculator, I go second vars, number 3, inverse norm, 0.4404. And we're going to find our z-value, negative 0.15. Z-values are always 2 decimal places. So the z-value here is negative 0.15. That z-value is negative 0.15. Okay, next problem. Let's draw a normal curve. it's normally distributed, so I'm going to draw a normal curve. I like to draw the curve to look at our picture. It says the average home costs $246,300. That's our mean. That's our average. And these are numbers, so that's not a z value. The z value for our average is always going to be zero. Average z value is always zero. Standard deviation is going to be 15,000. Find the minimum and to satisfy the middle 82%. The middle 82% means I have just as much data on this side as I do this side. So between here and here is 82% of our data. And another way of writing 82% in decimal form is 0.8200. When we do our probability or area under a curve, we always use 4 decimal places. So there is 82% of our data here. And we need to find z values here and here. That's what they're asking for. They're not asking for that. They're asking for the minimum. They're asking for the minimum and the maximum. This is the minimum number. If you look at the price of homes, this is the minimum and this is the maximum. The one in the middle is the average. So to find minimum and maximum, we had to start first with the z values of both of these. So I want to find the z value of the minimum. Let's find the z value of the minimum. You have to use the formula x minus the average divided by the standard deviation. So to find the z value, we want to find this x right here. And we know the average. We want to find that x value or that z value right there. By the way, x is the minimum price. This is what we're actually looking for. Our average was 24,600, and our standard deviation was 15,000. So I'm missing 2 things: the z value and the x value. We're looking for the x value at this spot and the z value. Well, I think I can find the z value at this spot. I think I can find the z value. I just have to know the area to the left of this curve. What is this area? If the red area is 82, wouldn't you say then the blue area is 18? Because 18% and 82% is 100%. So the area in blue is 18% because the area in red is 82%. So each blue, then, if you add the blues up, you get 18%. Then each blue is 9%. So if I can find the z value for 9%, I'm going to go to inverse norm again and put 9%. And the way to write 9% in decimal form is 0.0900, right? That's 9%, 0.09. So on my calculator, let me raise it up. We're going to do 9%. Uh-oh, what happened to my calculator? That's not good. Where are we? All right, here we are. So we're going to do second vars. First, we're going to turn it on. Second vars, inverse norm for 9%, 0.09. And it gives us a z value of negative 1.34. Negative 1.34 equals x minus 24,600 divided by 15,000. So I have to solve for x. Our goal is, by the way, we're doing all this work just to find this minimum value. So I have to go through all the solving for x. I'm going to change to black. To solve for x, I have to multiply both sides by 1,500 to get rid. I want to take this 15 to the other side. It's divide by 1,500. So I multiply this side by 1,500 and I multiply this side by 1,500. 1,500 times negative 1.34 is negative 2,100 equals x minus 24,630. So now I'm going to add that 24,630, add that 24,630, and x equals add 24,630, and the x value equals 226,200. So the smallest, the minimum price range is $226,200. Remember, that's the average. So we found this number, that the minimum price is that. To find this value, by the way, this is symmetrical, 9%, 9%. So if you put in 81 or 91% here, that's this, that'll give you this z value. Your z value for this side would be 1.34. I'm not going to finish the problem, but you're doing the same thing. Z max, now you're trying to find z max. Everything's the same, except you have to find this z value. Once again, if this is 9%, you have to go to the left. This would be 91%. So if you do a 91%, you should get a positive 1.34 because since this is symmetrical, this is negative 1.34 and this is positive 1.34. And then you go ahead and solve for x again. So I just wanted to show you that. Okay, next problem. We're normally distributed. Standard. Oh, I'm missing some problem. Oh, I'm missing. We're normally distributed. Let me see. I'm missing some. Um, I'm missing some of the problem. It says the average is 23.2 gallons. The average is 23.2. It says that above this. And then it says standard deviation is 2.7. Find the z value for more than 30.5. So once again, the average is 23.2, and we want to find for more than 30. We know 30 is to the right of 23.2, so we want to find the area under this curve, more than 30. more than 30. So to find this area, we have to have the z-value. To find the z-value of more than 30, we're going to use the formula. This is the average over standard deviation. Sometimes I use this as the average. Sometimes I use this. One's for a sample, one's for a population, but they're both the same. So to find this z-value, the x value we're talking about, more than 30, the average was 23.2 and the standard deviation was 2.7. So what does this z value equal? 30 minus 23.2 divided by 2.7, and I get a z value of 2.52 if I round it to 2 decimal places. So this z value is 2.52. We want to find a z value greater than 2.52, and it goes on over here to infinity. When we do this on our graphing calculator, you only have to type in 99 for infinity, because 4 standard deviations covers pretty much everything in the normal curve. So I just type in 99 to go to infinity. 99 standard deviations is a lot. So on our calculator, we're going to go to second vars again. And we're going to go to B. So let's do that on my calculator here. Second vars, and not B, I'm sorry, number 2. Normal CDF. Normal CDF. And if you hit enter for that, it says lower and upper bound. My lower bound is going to be a z value. You only type in the z values here. 2.59. This is the lower. And this is the upper, 99. For z value, 99 is infinity. So let's type that in. I'm going once again to second vars, number 2. And my lower is going to be whatever I said it was, negative 0.25, I think. Positive 2.52. See, I don't even know what I said. Positive 2.52. And the low, that was a lower, and the upper is going to be infinity. For z values, 99 is infinity. When I hit enter, 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 there's the area under the curve, 0.0058, and since this is 5 or more, it's 0.0059. So the area under this curve is 0.0059. You always round areas or probabilities under a curve to 4 decimal places. So we had to find this. We didn't know the z value. We had to find the z value. And then if you look to the left, this is 99. By the way over here, since this side is negative, the infinity for the negative side would be negative 99, just to let you know. All right, so here's another problem. Consider Social Security. That's right. I mean, this is the same thing as we've been doing, I think. Assume normal distribution with standard deviation. This is the mean right in the center. So it tells us our standard deviation is 121. Uh-oh. There we go. 121. If one fourth of payments are above 1277.45, find the mean. So we're looking for the mean. Find the mean. it says if 1/4 of the payments are 1/4 is 25%. So if I shade in 25% of this graph greater, and it says above, if 25% are above this Z value right here, 25% is above that, find the mean. Well, here's our formula for Z values. X minus the average, the mean, divided by the standard deviation. We have the standard deviation. We don't have the mean. We're looking for the mean. So we need to find this Z value first. And we know this is 25%. So we also know that the area to the left of the Z value is 75%. This area, if the right is 25%, this area is 75%. So I'm going to do an inverse norm for 75%. That'll tell me the Z value here. Inverse norm for 75%. Remember, you got to go to second vars. So on my calculator, I go, let's clear it, and hit second vars, number 3, inverse norm for 75%. And it tells us the Z value, 0.67. Since there's a 4, we leave it at 0.67. So this Z value is 0.67. In other words, in the formula here, we have 0.67 equals X. That's what we're looking for. We're not looking for X. Sorry. We're looking for the mean. X value is what we're looking for right now. Wait a minute. We're looking for the mean. Oh, we have our Z value. We don't have an X value, but we have the Z. Seems like we're missing too many pieces of data. Okay, so we did everything correct. We know the Z value for this spot is 0.67. We also know the X value, the 1/4 payment. We already said the X value for that spot. Let me see if I can, I don't think I can erase right now. Let me change my color. There we go. So the Z value, I'm going to bring it over here. The Z value is 0.67. Our X value is up here. This is the value we were talking about, 1277.45. We're looking for the average. That's what the question was. And the standard deviation was 121. So this is similar to the other problem. We just have to find the average, not the X value here. So I multiply both sides by 121, multiply both sides by 121. I'm trying to get this to the other side. Multiply this side by 121. Those cancel. So I do 121 times 0.67, and I get 81.07 equals 11277.45 equals the average, or minus the average. So I subtract the 1277 to both sides. Subtract 1277.45 to both sides. Minus 1277.45. And sorry, I'm running out of room here, and I shouldn't have used that light color blue. I end up with negative 1196.4 equals a negative x. So if I get rid of the negative by dividing by a negative 1, there's my x value. Oh, by the way, not my x value, but my average value. So my average equals 1196.4. 1196.4. That's what they were asking us. All right, and I have one last problem. This is a little different than the previous problem we just did. And you really have to know the difference here. This problem is taking a sample of 54 families. So none of our other problems took a sample. This formula for sample to find the z value for sample is different. The z value for a sample is x minus the average divided by the standard deviations divided by the square root of the number in the sample. So this z value is a little bit different. And we want to find the z value. Here's the average. And it says survey, the average is 17.2. So if this average is 17.2, we want to find the average at 17.8 and 16.8. The difference between 17.8, we want to find the area under 17.8 and 16.8. In other words, we have to find the z value for both of these spots. This is the formula you use for the z value for both of those spots. So this is the lower and this is the upper. Let's do the upper first on the right-hand side. The x value for the upper is 17.8. The average was 17.2 up here. Standard deviation was 2.5. And n is 54, the square root of 54. So let's put this into our calculator and see what we get for a z value. I have to write it right here. So on your calculator, make sure, I should show you this. On our calculator, we're going to type in 17.8 minus 17.2 divided by, put a parentheses around it, 2.5 divided by the square root of 54. And then I arrow over and finish my parentheses. And I get a z value of 1.76. Now, if we do the z value for the lower, the x value is 16.8. The average is the same, 17.2, divided by the standard deviation, divided by the square root of 54. So put this in your calculator. Parentheses 16.8. And by the way, this should be a negative. Do you see how it's the left side of the average? So z values are always negative on the left side of the average. The square root of 54, I'm going to arrow over. And I get a negative 1.8 if you round it to 2 decimal places. Here, the z value, I get a z value of negative 1.8. What did I say? 1.18. There we go. This z value is a negative 1.18. So on my calculator now, I have my 2 z values, and I want to find, it says, this is the symbology for finding the area between 16.8 and 17.8. In order to do that, these are not z-values. These are the numbers, the values. You have to plug in the z-values in the calculator to find the probability. This is going to be the lower, negative 1.8, and this is going to be the upper, negative 1.18. I need to remember that, negative 1.18, and the upper is going to be 1.76. So let's do that on our calculator now. So I'm going to go to second vars, and I want to do normal CDF, and my lower is going to be negative 1.18, and my upper is going to be 1.76. So you see, using the normal CDF, you do the left side and the right side, the lower and the upper. You plug that in, and it tells you the probability, or the area between those two curves, is 0.8418, because there's a 9 here in the fifth spot. 0.8418. So the area under this curve is 0.8418. That's the answer, 0.8418. The area between those two values. Since they're not z-values, you have to find the z-values and then use the normal CDF to do that. All right, I just have maybe one more to show you. If they ask, what's the probability that x is greater than, not x, I'm sorry, z is greater than 2.1. If z is greater than 2.1, they're telling, this is a normal curve. Here's z0, right? Average is z0. 2.1 is somewhere over here, a z-value of 2.1. Greater than 2.1 is finding this area, once again. So our lower limit is 2.1. Our upper limit, since it goes in these z-values, 99 is infinity. So on my calculator, I go 2.1 to 99. Second vars, number 2. Uh-oh, what happened there? And we're going, who knows where we're going? Let's see, 2.1 and 99. 2.1 and 99. And it tells us the area, once you hit enter, 0.0179. 0.0179. The area between that curve is 0.0179. Do you see how they're asking it? So this is just one way of asking it. If there's a z-value, you just plug it in. If there are x values or average values, if you do this, then these are not z-values. You have to find the z-values for these and then plug them into calculator. But if the probability gives you the z-values, you just plug the z-values into the calculator. Greater than 2.1 is 2.1 for the lower, and the upper will then be infinity, 99. All right, so that is the test 3 review. I hope this helps. I showed you the binomial distribution. I have a video on that. I don't have a video on normal distribution on the calculator, but I hope this video helped you with that normal distribution. Give me a call or shoot me an email if you have any questions at all.